Today's lesson is about absolute value equations. As you learned already, um, an absolute value can be changed to a piecewise function. For example, absolute value of x minus 2 is either x minus 2 when x is larger than or equal to 2, or negative x plus 2 for x less than 2. Therefore, absolute value of k in general is equal to either k or negative k. So we use this to solve absolute value equations. I'm going to start with an easy example. Let's say absolute value of x minus 2 is equal to 1. So in the first case, absolute value of x minus 2 is equal to x minus 2, and we just remove simply the absolute value. Therefore, x becomes 3. This is one solution to this equation. And in the second case, absolute value of x minus 2 becomes negative x plus 2. Therefore, negative x equals negative 1. And therefore x equals 1. So there are two solutions to this absolute value equation, 3 and 1. Okay, let's do the second example. The second example says that absolute value of 2x minus 3 equals x plus 7. So quickly we'll start with the first case, which obtains easily by removing the absolute value, by moving around the variables and the numbers. So we'll get 2x minus x equals 7 plus 3. Therefore, x equals 10. So in the second case, absolute value becomes its opposite. So it becomes negative 2x plus 3 equals x plus 7, which means x equals negative 4 over 3. And we are done with the second equation. The third equation is more interesting because it has more to it. Look, x plus 5 equals 1 minus 2x. The first case implies that x plus 5 equals 1 minus 2x. Therefore, 3x equals negative 4. Therefore, x becomes negative 4 over 3. In the second case, negative x minus 5 equals 1 minus 2x. Therefore, x equals 6. But x equals 6 might not work. Let's try to verify that. If x equals 6 is a real solution, both sides of the original equation, the one that I make yellow here, must be the same. Let's give it a try if they are same. So by plugging x, 6, we'll get absolute value of 6 plus 5 equals 1 minus 2 times 6. The left side would be absolute value of 11, and the right side is negative 11. Therefore, we will get this, which is absolutely incorrect because 11 can't be equal to negative 11. Therefore, 6 is not a real solution. So it means sometimes the solutions that you get, they might not work. How do I know that? Let's see. So we know the answer to an absolute value must be positive. The inside absolute value could be anything. For example, inside the absolute value can be -3, but absolute value of -3 is always positive. Therefore, the outcome of an absolute value must be positive. Therefore, if you look at this equation, absolute value of x plus 5 equals 1 minus 2x. So 1 minus 2x cannot be a negative number. If, for example, you see an equation like absolute value of x equals -5, it's absolutely wrong and it doesn't work because the answer to an absolute value can't be negative. This is why 1 minus 2x must be larger than or equal to 0, or 2x has to be less than or equal to 1, or x less than or equal to 1/2. It means the solutions that we get must be less than or equal to 1/2, otherwise they won't work. And if you look at the solutions that we got, 6 does not meet this requirement. And then 6 can't be considered as a real solution. Some books, they call 6 extraneous solution, the solution that is, looks to be a solution, but it's not. Okay, let's go to the next equation, which is a quadratic one. So absolute value of x squared plus 3x equals 5x minus 1. Okay, quickly, case number 1 would be x squared plus 3x equals 5x minus 1. X squared plus 3x minus 5x plus 1 equals 0. I moved everything to the left side. Therefore, x squared minus 2x plus 1 equals 0. Everyone knows that this can be written as or x equals 1. Later on, we'll determine whether x equals 1 is a real solution or not. Let's continue to the second case, which says negative x squared minus 3x equals 5x minus 1. I'm going to move everything to the right side because I don't like the leading coefficient to be negative. This equation is not factorable, therefore I'm going to use quadratic equation and the quadratic formula. So if you use quadratic formula, delta would be b squared minus 4ac, which is 64 plus 4, which is 68. Therefore, x becomes negative b plus or minus square root of 68 over 2a, which is 2. I'm going to simplify it more. Negative 8 plus or minus. So 64 can be written as 4 times 17. 4 is a perfect square. This is why I take it out. So it becomes 2 square root of 17 over 2. And finally, the answers in the simplest form would be -4. Okay, so far we've got 3 solutions. 1 and -4 plus square root of 17 and -4 minus the square root of 17. Now I need to determine which of these solutions work actually. So one way to determine whether or not they're working is just to verify the solutions. For example, I'm going to do it for x equals 1 with another color. So I'm going to verify x equals 1. This is why I'm going to put it in the original equation. Left side becomes 1 plus 3. Right side is 5 minus 1. 4 becomes 4, which is correct, which means x equals 1 is a real solution. Even though verifying here was very simple because x equals 1 is a simple number, but how do you want to verify -4 plus or minus square root of 17? That's a little bit, difficult, right, to achieve. This is why I'm going to use a better method that I explained in the previous example. I'm going to write it with blue. I explained that 5x minus 1 cannot be a negative number. This is why in the previous example I explained that the outcome of an absolute value is always positive. Therefore 5x minus 1 can't be a negative number. This gives us 5x larger than or equal to 1. By dividing both sides by 5, we'll get x larger than or equal to 1/5. So it means all the correct solutions, the real solutions, must be larger than or equal to 1/5. Obviously 1 is larger than 1/5, so this is why 1 works. However, -4 minus square root of 17 is obviously a negative number, therefore it can't be larger than or equal to 1/5. Thus, x equals -4 minus square root of 17 is not a solution. Okay, let's take a look at -4 plus square root of 17. So I think if you use your calculator, let's see what is the value of square root of 17 minus 4. If you use your calculator, there are many ways to actually determine whether it's less than 1/5 or larger, but I don't want to face those complications for this question and this level. This is why we simply use our calculator, and we'll see it's 0.12 nearly. So which is obviously less than 1/5. So therefore this solution also, this number also can't be considered as a solution. So it isn't a solution. Okay, I think that would be enough for this lesson. I think you learned how to deal with these absolute value equations and how to determine that some solutions might not work and some solutions are extraneous and you need to reject them. Thank you for watching, and in the next lesson I'm going to go deeper into these equations.